So we're going to start with a few examples on how to use these LOL diagrams to represent how energy is transferred. So when we're doing this, remember, we are not doing energy chemically yet. That would be when a chemical reaction occurs, and we aren't having chemical reactions at this point. We are just doing changes in temperature and changes in phase. So we'll start out with one first. So the first one is water in a syringe boils when the volume of the syringe increases. So what's happening here? Boiling occurs because of a reduced pressure. So in this case, that means the temperature is going to be constant. There is no change in temperature. We are reducing the pressure on this water on the top of it, and so that means boiling is going to occur at a lower temp than normal. So what we're looking at here, our system first would be the water in the syringe. So we have to go back and look. Initially, we're going to say this is at room temperature, so we're going to go with 2 bars, and it's water, so 2 bars would be for the liquid. Okay. Now, when it boils, it changes phase. So at the end, we would have a vapor or a gas, and the temperature we said is staying constant, so it would be this. I'm going to keep the 2 bars. Now, we've got to remember we have to deal with the law of conservation of energy. And so in this case, since I have 4 units over here of energy, and I have 6 units here, that means energy had to be transferred into the system. I'm going to call that Q. So this would be heat energy to make this occur. So this means this would be an endothermic process. So we'll go to the next example. We'll do these 4 examples to get an idea of so we're going to get an idea of some different examples so that we can identify the energy transfer. So this one, now we're going to look at a tray of ice cubes. It's placed on the counter and it becomes water at room temp. So we're going to have another change in phase here, and we're going to have a change in temperature also. So if I was to look at a graph for this, if I was to sketch a temperature versus time graph, this also could be energy, because we could be talking about the energy over the time. If I was to sketch that, it would look something like this. So I have ice cubes that are very cold, and they are going to absorb heat. So the temperature is going to rise, and then they're going to melt. So if I was to look at this, first they have to absorb up to 0 degrees Celsius, and then they would melt. So we know that a change in temperature and a change in phase never occur at the same time. So I'm going to start with my ice. It's my system, and these are at a -8, so that's below room temperature. And they're ice, so it's 1 bar, we said, for a solid. At the end, so they have to go through the warming. So the temperature is changing. And then we said these were warming up to room temperature, and the phase also changed. Now they're a liquid. So if I look, I have 2 units over here of energy. I have 4 units here. This means these had to absorb Q, which is my heat energy, in order to do that. We'll use the law of conservation of energy to say that energy is staying within my system. So this was just an example of absorbing energy. So this would be an endothermic process again. So this would be my third example. A sample of water warms up after it is exposed to the sun for an hour. So we'll say the sample is at like room temperature. So my system is going to be my water. And I'm going to just identify it as being room temp and 2 bars per phase. So it's just going to be warmed up. So if I did a temperature versus time graph here, all this is warming, so it's just going to be an increase in temperature. So I'm going to say it's going to warm up this much, and it's still a liquid. Analyze my units. I have 4 units on the left side, I have 5 on the right. This means this took in energy, and it was, call that Q. So this is heat energy. And since it's from the sun, from its radiation. So that's the radiant energy that would be transferred in. This would be an endothermic process. Okay. The last one is temperature of the skin decreases when sweat evaporates from the skin. So we're looking at our system would be the sweaty skin. So we're going to look at that. So to start with, we are at body temp. And that's higher than room temp, so I'll just go with 3 bars. And the phase would be, it's liquid, that's sweat on there. And in the end, this cools down, and the phase energy increases because that sweat became a vapor. So we're looking at the fact here that Q is going into the system again. This is endothermic. And it is causing the sweat to evaporate. And when that does, Q leaves the body and it causes it to cool down. So that would be our last example of being done.